Hello everyone! Meet again in this chapter for learning linear quadratic and quadratic two-variable equation system. So what we will learn for this topic? This is the learning outcome. The first one, we will determine the position of a linear and quadratic graph. And after that, we will find out an algebraic solution, how to determine the solution of linear quadratic and quadratic equation system. So for the first one, you have the worksheet already, so now you can check what you have with this relation of linear and quadratic graph. So for the first one, when you have a parabola, a curve, and a line, and they meet at two distinct points, you can calculate the discriminant of the new equation form after substitution, and the discriminant will be greater than 0. We have two different positions. It can be open up parabola and open down parabola with the two meeting points with the line. And in this system, we know that the 2 points will be the solution of the equation we have. For the second one, if the line touch the curve in these two different positions, we can count the discriminant of the new quadratic equation form, and the discriminant value will be equal 0. And in this case, the equation system has only one solution. And the third one, the d less than 0 for the line which doesn't intersect the curve at any points in these two positions. And for the equation system, it means the system has no solution or no meeting points. So now we will discuss the second point about the solution, how to find out the solution of linear quadratic equation system. In this system, you can see at this example 1, we have one equation that is a quadratic with the order 2 and the line 2x plus 3y minus 7 equals 0. To find out the solution, as we know in algebra, we can do the substitution here. So we will substitute from 2x plus 3y minus 7 equals 0, change the form, become y equals 7 minus 2x over 3. After that, we will substitute this value of y to the quadratic equation. In here, the y value is 7 minus 2x over 3. So we can simplify. We multiply it by 3 to eliminate the fraction. In here, we have the fraction is 9 multiplied by 3, so the denominator is 3. To eliminate this 3, we will have 6x squared plus 7 minus 2x squared plus 3x equals 39. And after simplify this equation, we have 2x squared minus 5x plus 2 equal 0. So the factors will be 2x minus 1 and x minus 2 equal 0. And the solution for x value or the abscissa will be a half or 2. We substituted back to y value 7 minus 2x over 3. So we have y equals 2 for x equals a half and y equals 1 for x equals 2. Means for this equation system, we have two solutions, x comma y, the first point, and x comma y for the second point. Here is the solution written in the braces, and if we see the figure of this system, the quadratic will be an ellipse in this shape, and the line will be this blue line, which intersect the ellipse in 2 points, a half comma 2 and 2 comma 1. Okay, so let's move to the third part about the solution of quadratic equation system. Let's see example 2. In this case, we have both equations in the order 2 or both are quadratic. So what do we do here? In this example, one of the quadratic equation can be vectorized. So the x squared minus 3xy plus 2y squared equals 0 can be factorized, become like this. We have the part of x and we have the part of y. The factors are x minus 2y and x minus y equal 0. From this factor, we have two equations obtained. X minus 2y equals 0 and x minus y equals 0. So from the first one, x can be substituted become 2y, and from the second one, x is y. So what do we do now? For this simplified factors of the first quadratic, we will substitute it to the other quadratic equation, x squared minus xy minus y squared equals 16. So let's substitute x become 2y and simplify. So we have y squared equals 16 and we have two values of y satisfied, that is 4 and minus 4. For these two values, we will have x, which is 2y, so that x in here is 8 or x is minus 8. For the second equation, x equals y, we do the same thing. We substitute it to x squared minus xy minus y squared equals 16. And when we simplify this equation, we got minus y squared equals 16. So since a complete square cannot have any negative number, in here y squared cannot be minus 16, then from this possibility, we don't have any answer. So in conclusion, we only have two pairs of points, that is 8, 4 and minus 8, minus 4. So we can figure out the graph and the line like this. The first quadratic, x squared minus xy minus y squared equals 16, is actually the conic section which is named a hyperbola, and the other quadratic equation, x squared minus 3xy plus 2y squared equals 0, which can be factorized, is actually two lines intersecting at 0, 0. So we can see it here that the first line doesn't intersect the hyperbola, so that's why we don't have any solution or no possible answer. And from the other line, we got two solutions, meets the hyperbola at minus 8, minus 4, and 8, 4. So that's how we can describe the position of the curve, the quadratic, and the two lines which is also a quadratic. So this is the system and the solution. Okay, so that's all for today. We'll continue the third example for the quadratic with different method of solution. Let's continue this at the next meeting. Bye bye everyone, stay healthy and God bless you all.